Right, this is the beginning of chapter 18. This is covering pages 342 to 349. We're going to move into a study of a fancy term called thermodynamics, which is really just a study of heat and how heat moves. And so when you hear the words thermodynamics, it usually sounds fancier than it really is. But all it really is a study of how you can use heat to make mechanical energy. So, thermodynamics, by definition, is the study of heat and its transformation to mechanical energy. So, if you can take heat and use it for something, now we are making it useful, and that is thermodynamics. So, the foundation of it, and really the first law of thermodynamics, there's two laws, comes from the idea that energy is conserved and it transfers from one place to another. And when heat is transferring, which is heat is a type of energy, it's always going to flow from hot to cold, which is what we learned in the last section, the last chapter test we took. So heat always flows from hot to cold, and energy is conserved when it's doing that. So what is lost has to be gained somewhere. That is the first law of thermodynamics. Now, when we're talking about temperature, understand that there is no upper limit. They don't know how hot something can get. What we do know is that once you hit a certain temperature, the phase that you'll find matter in, if you're going to be in that region of temperature, is going to be plasma. So the hottest places that we can think of would be inside of stars, and the matter inside of stars is going to be plasma. Now, there is a lower limit to temperature. There's only so far that it can go, and then it won't get any colder than that. We would call this absolute zero. Now, keep in mind, the coldest place that we can think of is space itself, and even space is not absolute zero. So we've never gotten there. It is theoretical only, but they believe that if you could get all the way to absolute zero, that there would be no movement whatsoever within the atoms. It would be completely still if you could get all the way to absolute zero. So there are no negative numbers. So sometimes when it's really, really cold outside and the weathermen are, telling you the weather outside, and they'll say, oh, it was 20 below zero last night, whatever. That never happens in Texas. But you would use negative numbers on the Celsius or the Fahrenheit scale, and you will never use a negative number on the Kelvin scale. So absolute zero is 0 kelvins, which that is, rather than having like a little degree sign with a C or a degree sign with the F like you would for Fahrenheit or Celsius, 0 degrees Kelvin is just a capital K, as opposed to having a little degree sign. You wouldn't have a degree sign at all. So the first law of thermodynamics, it says that when heat flows to or from a system, so either heat is gained or lost, then it's going to gain or lose that amount of energy. So however much heat is applied is how much energy you're going to gain, and or however much energy is lost, that is the heat flowing out of it. Another way of looking at it would be heat added to the system is an increase to your internal energy, because remember, internal energy is the sum of all the energy that's happening inside. So it's kinetic energy and potential energy and chemical energy and rotational energy and vibrational energy. Any energy that is in it is going to be in your internal energy. And so when you add heat to that system, you're increasing your internal energy, and then you are able to do work within the system. So heat allows external work to be done. So internally, you're increasing your energy. Externally, you're able to do work by adding heat. Now, what you got to keep in mind, though, this, remember, our first law of thermodynamics is similar to the law of conservation of energy. You're never going to get out more than you put in. It's kind of a law that goes just along with life, is if you want to get something out of whatever you're doing, you're going to have to put the effort into it. And sometimes you're going to put in way more energy and effort than you're going to get benefit and return, at least short term. So it's the same thing. Your energy output is never going to be more than your energy input. Okay, so going out and buying a lottery ticket so that you can make billions of dollars on when you guys are older, billions of dollars on Powerball or whatever they are, that you're putting very little energy into that, and you might seem like you're getting a lot of output from it, but I guarantee you that there are problems that come with that. And most people spend thousands and thousands and thousands of dollars buying lottery tickets and never ever winning. So in their case, it is not an efficient system to try to earn tons and tons of money. Now, anytime you take, so remember thermodynamics is having to do with heat, but if you take a system of air, an enclosed system of air, and you change the pressure on it by changing its volume, if you'll recall back to Boyle's law, you can change your density. If you change the pressure, the amount of space that a gas takes up, then you can increase pressure on it. Well, when you do that, but you don't add heat, you're going to change your temperature. So taking a gas and either letting it have more space, like it expands, or letting it have less space because you compress it, you are going to change the temperature, but you're not going to use heat at all. This is an adiabatic process. So anytime you are changing the temperature of something without using heat, that's an adiabatic process. So these happen tons and tons of places in weather phenomenon, mainly because of the air pressure that are going on. So you've got normal air, atmospheric pressure pressing down on our air here at sea level. As you go up in the atmosphere, then there's less pressure. When the air rises because it's hot, it's going to expand when it's under less pressure. When it expands, now it's going to cool. So that's an adiabatic process or an adiabatic process. So if you're interested in being a meteorologist, physics comes into play with this. So meteorologists are going to use the first law of thermodynamics, tons and tons and tons. So there are sections of air, they call them parcels, and they flow up and down. They kind of stay together, or air masses like to stay together. Now, imagine you got a mountain. So they're going to flow up the mountain. Well, as they change elevation and they go up, they expand because there's less pressure, and when it does, it cools. So you're going to have a nice cool one side of the mountain, and as it flows over the top of the mountain and flows back down the other side, now it is undergoing a pressure change and it's being compressed. Compressed air gets hotter, and so you can have air that is coming down, particularly they call them over the Rocky Mountains. The air that is sweeping down over the east side of the mountains, the Rocky Mountains, out into the plains of Nebraska and Kansas, tends to be much warmer air because of the pressure change of going from in the mountain area where there's low pressure to higher pressure, which makes it warm. They call these Chinook winds. So Chinook winds are going to warm a certain area of land because they are warm winds that are blowing. And the reason they're warm doesn't have anything to do with the sun or the heat of the earth. It has to do with the change in pressure in that parcel of air. El Nino, I haven't really heard a whole lot about this lately, but it was a big phenomenon for a while there. I think they're now calling it La Nina. But there are adiabatic processes that happen out over the ocean, and it can cause huge changes in weather patterns all over the whole United States. El Nino was one of those. La Nina is another one. So sometimes you'll have a temperature inversion. I want you to think of what an inversion means. Inversion means what it is flipped, right? So if you're doing an inversion in math, your reciprocal is an inversion. You flip it. Well, a temperature inversion is where your temperatures are not like they're supposed to be. Normally, your warmer air is going to be on bottom and your cooler air is going to be on top. So a temperature inversion is when you've got cold air trapped underneath hot air up above it. A lot of times this will happen over large cities, particularly that are near the ocean. It happens over Denver, but it's because of the mountains. And the adiabatic processes are responsible for that. So you've got cooler air that is down and it can't rise because the hot air is on top of it. And so it's trapped. And so it traps a lot of the smog and the smoke and the photochemicals and stuff that make the air really dirty. That's why it happens there. It's not because the cities are huge. It's because of temperature inversions and the air getting trapped and not being able to move the way it normally would move. All right, there's a quiz tonight. So go ahead and click on the link and do the homework, and I will see you in class.